Okay, so the only actual lecture that you're going to get in the organic chemistry unit is about the idea of functional groups. And functional groups are really important because they're the thing that makes organic, or the compounds in organic chemistry different. If it was just all carbon and hydrogen, it would be pretty simple, but the fact that there are different classes of hydrocarbons that we're going to talk about today change things up a little bit. Now, I am aware that what you're looking at here is not identical necessarily to what you have in your note packet. So what I'm going to do is I'm going to do the examples on here, and then at the end, I'm going to go ahead and do the examples in your note packet so you have two things to look at in terms of how to work through these. So the first functional group that we have to talk about is a group called the alcohol. The alcohol, by name, ends with OL. And its identifying functional characteristic is the OH. And its generic form or structural formula would be something like ROH. Now, I have to define this for a second. R is a generic name or a generic indicator of the actual parent chain or the longest continuous chain of carbons in the compound. Continuous, I'm sure I spelled that wrong. Continuous chain of carbons in the hydrocarbon. So in the case of methanol, a couple of things that I see right away is I see that the functional group is OL, so it tells me it's an alcohol. The AN tells me that there is all single bonds, and the meth tells me it's a 1 carbon long compound. So I'm going to draw my carbon, and there's all single bonds. There's nothing I really have to do about that. And then attached to the carbon, I'm going to add an OH, because that's what makes it alcohol. And then to that, I'm going to add hydrogens to make sure that the carbon has 4 bonds. And that's it. That's methanol. And in your notes packet, you see 1 propanol. We'll talk about that one at the end, because I don't necessarily have the room for it here. The other group is something called alkyl halides. You might remember or be familiar with the phrase halide, like halogen. These are the elements in the halogen columns, group 17 of the periodic table. They usually have a prefix, like fluoro or chloro or bromo or iodo. So the identifying functional group characteristic here would be F or Cl or Br or I. But because there's 4 different types that we could pick from, a lot of times what we'll do is we'll just give them a generic format as X. So in this case, we would call it Rx. So when I go to draw chloromethane, for example, first of all, I see that I have all single bonds. I see that it's a 1 carbon long chain, and I have a chloral group attached to that. So again, I'm going to draw my carbon, my 1 carbon long chain. Attached to my 1 carbon long chain, I'm going to put chlorine, and then to that carbon, I'm going to attach hydrogens. And that's it, chloromethane. And I know in yours you have 2-bromo-1-butene. We'll talk through that in a second. Aldehydes are a different class of functional group that has a carbon with an oxygen that is double bonded to the first carbon in the chain. So what that would really kind of look like is carbon double bonded to an oxygen. And we would signify that as, here's the rest of the chain, here's my carbon, and double bonded to that carbon is an oxygen. And then to that, there would be 1 singular hydrogen because, well, we have to make sure the carbon has all 4 bonds. So in the example here, ethanal, the Al tells me that it is an aldehyde. The AN tells me that they're all single bonds. And the eth tells me it's a 2 carbon long chain. So I'm going to draw my 2 carbon long chain. I'm going to add my single bond, and I'm going to add the double bonded oxygen to the first chain, to the first carbon. And because I'm numbering my chain, I'm going to number 1, 2. Then I have to go back and add hydrogens. So I'm going to put 1 hydrogen there because that carbon now has 4 bonds, and I'm going to put 3 here. Okay. So those are your aldehydes. Another type of functional group is something called the carboxylic acid. You'll identify it by name when you see oic acid. The way that the identifying characteristic is a carbon double bonded to an oxygen, and it's single bonded to an OH, and it is on the first carbon. So when I go to draw this, I would have R, which is the rest of the chain, carbon number 1, and then double bonded to that carbon is oxygen and an OH. But the key here, the really important thing, is this has to be carbon number 1. So the double bonded oxygen YGN and the OH have to be on the first carbon. And so the example that I'm going to go through here is ethanoic acid, okay? So ethanoic acid, this part right here tells me it's carboxylic acid. The AN tells me they're all single bonded, and the Eth tells me it's, wrong guy there. The Eth tells me it's 2 carbons long, okay? So I'm going to draw that. So I'm going to take my 2 carbons. I'm going to single bond them together. And on carbon number 1, I'm going to double bond an oxygen, and I'm going to single bond an OH. That carbon now has 4 bonds, so I'm going to leave it alone. I'm going to go back and add hydrogens. And now that's a finished structure. The next one is ether. You're going to want to say ether, but it's not. It's ether. This one has an oxygen that is held together by 2 branches. Oxygen that separates 2 branches. So it would look something like this, where we would have R, oxygen, and then R prime, because we have branch 1. Oops. 1 and branch 2, or branch prime, however you want to think about it. So in a dimethyl ether, what that really looks like is on one side I have a methyl branch attached to a carbon or an oxygen in the middle, and on the other side I have another methyl branch, and that's really all that it is. So here's what it would look like. It's a dimethyl ether. Not too bad. The next one is a ketone, and ketones, their functional group is a double bonded oxygen somewhere in the middle of the chain. It's just not on the first carbon. So double bonded oxygen, in the middle of the chain. So it would look something like, here's my carbon, and attached that somewhere in the middle of the chain would be a double bonded oxygen. But the generic format for that would be something that looks like this. So we would have R bonded to carbon, also bonded to R prime, because that's another oxygen, or that's another part of the chain, or yeah, that's the rest of the chain, and then double bonded to that in the middle would be an oxygen. So there's 2 different ways to name it. There's 2-propanone, which is the way that I sort of learned it, or ethyl methyl ketone, or methyl methyl ketone. The methyl ketone is like the really old way to do it. I don't generally teach it, but basically it says branch, and then the ketone in the middle. It gets a little confusing. I like to teach it talking about just propanone in general and then saying where it is. So 2-propanone would be, well, ONE in this case would tell me I have my double bonded oxygen. Okay, and prop tells me it's a 3-carbon long chain. So I'm going to draw my 3-carbon long chain, carbon, carbon, carbon. And so then I would have single bonds here. And on the second carbon, I would double bond an oxygen. And then I would go back and add my hydrogens. So in this case, I've got 2-propanone, and that's because the ketone is a double bonded oxygen in the middle of the chain. Esters are a little bit more complicated. The identifying structural formula is there's a carbon, and to that carbon there is a double bonded oxygen and a single bonded oxygen, and then you have more stuff off to the side of that. So what really we have here is we have a chain side and we have a branch side. So when we draw our functional group generic form, what I have is R attached to a carbon that is double bonded to an oxygen, single bonded to an oxygen, that is attached to R prime. Now, in this case, R prime is a branch, okay, and R by itself is the chain. Okay, so here we have methyl ethanoate. Okay, so the O8 tells me that it's my functional group. It's the double bonded oxygen, single bonded oxygen. The AN tells me it's all single bonds. Eth tells me it's a, oh boy. Eth tells me it's a 2-carbon long chain. Now, the YL tells me that's my branch, and the meth tells me it's a 1-carbon long branch. So I'm going to start drawing my chain first. So I have a 2-carbon long chain. Oops, wrong color. A 2-carbon long chain. And they are single bonded together. And to the number 1 carbon, because I'm drawing this, I'm going to double bond an oxygen and single bond an oxygen. And then to that single bonded oxygen, I am going to bond a branch, which in this case is a methyl branch, which would be this. Now I'm going to go back and add hydrogens to my chain, which would be this. So this part right here, this is my chain, and this is my branch. Okay, so that's kind of how the esters work. Glycols are pretty simple. All glycols are alcohols, but they have more than one alcohol group attached to it. So there's usually a number prefix associated with the OL. So diol would be 2 alcohol groups. Triol would be 3 OH or alcohol groups. And so if I was to draw a generic sort of format for that, it would be something like where I would have OH and OH. Oh wait, that's actually what I was supposed to draw over here. Well, how convenient. Let's talk about it. The OL is OH. The di tells me there's 2 of them. The AN tells me it's all single bonds. The Eth tells me it's 2-carbon long chain. Now, the 1 and the 2 tells me where on the chain the OHs are. So I'm going to draw my structure. Carbon, single bonded. I'm going to number it 1, 2. So then I'm going to add an OH here and an OH here, and then I'm going to go back and add hydrogens. And that's it. Okay, and then we've got 1 more, or 2 more rather. We have amino groups, we have nitro groups. Amino groups can also have, they have the beginning prefix of amino, but they can also have an ending of ine, so ethylamine, depending on how you want to read it. But the thing that we're looking for here is in NH2, and so the generic format would be R NH2. And so then ethylamine, well, the mean or INE issue tells me it's my NH2 group. The A tells me it's all single bonded. The ethyl part tells me it's a 2 carbon long chain. So I'm going to draw my 2 carbon long chain. So it's carbon, carbon, and then attached to that is a single bond. And then I'm going to attach my NH2, and it just says, it doesn't tell me I have more than one, so I'm just going to attach it to the first one, which is NH2. And then I'm going to go ahead and add hydrogens, like that. If there was more than one amine, or if it was a bigger chain than just 2, I would have like 2 ethylamine, something like that, to tell me it was on the second carbon. And we'll do an example of that in a minute. And then lastly is the nitro group. It's NO2, which would be R NO2. And so the example here is 1,3,5 trinitrohexane. Ane tells me it's all single bonds. Hex tells me it's 6 carbons long. Nitro tells me it's my NO2 group. Tri tells me there's 3 of them, and the 1, the 3, and the 5 tells me where the nitros are. So if I was to draw this structure, carbon, 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 1, 2, 3, 4, 5, 6, I'm going to single bond them together. Then I'm going to go and number my chain, 1, 2, 3, 4, 5, 6. And on the first one, I'm going to put in NO2. On the third one, I'm going to put in NO2. And on the fifth one, I'm going to put in NO2. I'm going to go back and add my hydrogens. And so that would satisfy to make sure all the carbons have 4 bonds. So now what I'm going to do is I'm going to go back and do examples in your packet, and I'm going to start with the first one and work my way through them just so that you have one more set of things to look at. So alcohol, your example was 1-propanol. So the OL tells me I have OH. The AN tells me it's single bonded. The prop tells me it's a 3 carbon long chain. And the 1 tells me the location of the OH. So when I go to draw my 3 carbon long chain, I'm going to go ahead and on the first carbon, I'm going to add my OH group. And then I'm going to go back and I'm going to add hydrogens so that every carbon has 4 bonds. Like that. For the alkyl halide, your example was 2-bromo, 1-butene. So a couple of things. The ENE tells me it's double bonded. The bute tells me it's 4 carbons long. The 1 tells me the location of the double bond. The bromo tells me that it is a bromo alkyl halide attached, and the 2 tells me its location. So I'm going to draw my structure with my 4 carbons. And after the first carbon, I'm going to put a double bond because that's what I'm told. On the second carbon, I'm going to add my bromo, my alkyl halide group, and now I'm going to go back and add all of the hydrogens that I need. So this first carbon is bonded twice, so I'm going to put H and H, that gives me 4. This middle carbon, the second carbon, is has 4 bonds already. So then we have H, 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 and everybody's happy in that part. The next group was the aldehydes. And your example there was 3-methyl butanol. So the Al tells me that I have a double bonded oxygen. The AN tells me they're all single bonds. The bute tells me it's 4 carbons long. The methyl tells me I have a 1 carbon long branch, and the 3 tells me that's location. So because the aldehydes are the ones where the carbon has, the number 1 carbon is where the double bonded oxygen has to be, I'm going to draw my structure, 1, 2, 3, 4, and I'm going to do all of my single bonds, and then I'm going to go back and double bond, I'm going to count my chain out, 1, 2, 3, 4, and then I'm going to double bond my oxygen to the first carbon, and then I'm going to, on the 3rd carbon, I'm going to add my methyl branch, and now I'm going to go back and add hydrogens so that every carbon has 4 bonds, and then everybody's in good shape there. The other example that you guys had were for carboxylic acids. Okay, and remember those are the ones where the carbon is double bonded to the oxygen, single bonded to the OH on the first carbon, and your example was propanoic acid. So in this case, the oic acid tells me it's my double bonded oxygen, single bonded OH. The AN tells me it's single bonds, and the prop tells me it's a 3 carbon long chain. So I'm going to draw that, all single bonded together. And then on my number 1 carbon, 1, 2, 3, I'm going to double bond in oxygen, and I'm going to single bond in OH. And then I'm going to go back and make sure that all my carbons have 4 bonds rather, and then everybody's happy there. In your packet, the ether that you were working with was ethyl methyl ether. So that tells me, because it's an ether, that I have an oxygen somewhere separating 2 branches, and because I see that I have a 1 carbon long methyl branch and a 2 carbon long ethyl branch, and because it's an ether, that tells me that there's an oxygen separating them two, and it actually doesn't matter which side you write them on. So I'm going to have my 1 carbon long branch here and my 2 carbon long branch here, and then I'm going to go back and add my hydrogens so that each carbon has 4 bonds. And we have ethyl methyl ether. The other examples that I have to go talk about was 2-butanone. That's the way I'm going to go through it. So that was your ketone, which again was 2-but-and-one. So the ONE tells me I have that double bonded oxygen somewhere. The AN tells me it's a single bond. The but tells me it's 4 carbons long. And the 2 tells me the location of the oxygen, so the double bonded oxygen. So I'm going to go back and I'm going to write in my 4 carbons. I'm going to single bond them together, and then I'm going to number the chain. I'm going to double bond my oxygen to that 2nd carbon, and then I'm going to go back and add hydrogen. And everybody's satisfied there. There's a couple more we got to do. As a matter of fact, I think it's 4. One of them is an ester. The esters have the carbon double bond of the oxygen, and then the single bonded oxygen is attached to the branch. In your example, you had an ethyl propanoate. The OATE, it tells me that I have my double bonded oxygen and my single bonded oxygen. The AN tells me it's all single bonds. The prop tells me it's 3 carbons long. That's my chain. The YL tells me I have a branch, and the Eth tells me it's a 2 carbon long branch. So I'm going to start with my chain, which is 3 carbons long. So here's my chain. So 1, 2, 3. Single bond them together. I'm going to number them 1, 2, 3. I'm going to now double bond my oxygen, single bond my oxygen, and then I'm going to add my branch. So, which is an ethyl branch, so that's going to be 2 carbons long. and those are all single bonded as well. And then I'm going to go back and add hydrogens so that every carbon has 4 bonds. Like that. And then we have glycols, where your example was 1, 2, eth, and diol. The OL tells me there's an OH group. The di tells me there's 2 of them. The AN tells me there's single bond. The eth tells me it's 2 carbons long. And the 1 and the 2 tells me where the oxygens are located, or the hydroxides are located. So here I have carbon, carbon, single bonded together. I'm going to put my OH here, my OH here, hydrogen, 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 and everybody's happy. The only one that we need to do yet, because the nitro group I think is one that you had in your packet, is the amine. And that is 2-amino, 2,4-dimethyl, pentane. The ane tells me they're all single bonded. The pent tells me it's 5 carbons long. The YL tells me I have a branch, and the meth tells me it's 1 carbon long. The di tells me there are 2 of them. The 1 and the 2 tells me, or the 2 and the 4 tells me their location. The amino is the NO2, and the 2 tells me that's location. So let's draw the structure. 1, 2, 3, 4, 5. All single bonded together. And I'm going to number my chain. So on my second carbon, I'm going to put an NO2. On my second carbon, I'm also going to put a methyl group. And on my 4th carbon, I'm going to put a methyl group. And then I'm going to go ahead and add hydrogens. So that every carbon has 4 bonds. And that pretty much covers it. We did the 1,3,5 trinitrohexane earlier. I don't think I really need to do that one again. Your practice, your homework tonight is to do the naming mixed compounds of hydrogens, or naming functional group worksheet. So there's that. Good luck, and check your answers with the posted answer key on Google Classroom.